Hi everyone, today I'm gonna present our experiment. It is E4, which is common collector amplifier. We can call it commuter follower, and my name is Lee Jia-jun. So in our team we have me, which is Lee Jia-jun, and my team is Sharifah Fradana. So for the objective, the first one, we need to measure the input and output impedance of the common collector amplifier. The second one is we need to measure the power gains of the common collector amplifier. And the last one, we need to study the phase relationship between the input and output signal of the common collector amplifier. For the equipments, we have 12-volt DC power supply, dual channel oscilloscope, digital multimeter, function generator, transistor BC108, project board with connecting wires, resistor 390 ohm and 10k ohm, potentiometer 1 kilo ohm, capacitor which is 10 microfarad 50 volt and 100 microfarad 50 volt. For introduction, common collector amplifier is a type of transistor circuit that boosts current. It takes a small input current and produces a much larger output current. The output current closely follows the input voltage. It is about 0.7 volts lower. It's also called emitter follower. So it is a current amplifier that maintains a steady voltage, making it useful as voltage buffer in electronic circuit. For procedures, set up the circuits as shown in the figure 1 but do not connect potentiometer R4. For part 1, calculate and measure the DC operating voltage found in a common collector circuits. For part 2, set AC source to be 1 kHz frequency and 150 mW peak-to-peak voltage. Measure the output voltage and calculate the voltage gain. For part 3, insert R4 back to the circuit and adjust potentiometer until Vout is half of the value obtained in part 2. Then remove R4 from the circuit and measure its resistance using digital multimeter and calculate the output power. For part 4 and part 5, use both channels on the oscilloscope to display the input and the output signals of the CC amplifier and capture the real picture of the waveform. Calculate the power gains and determine the phase difference for the two signals. So for the start, these are some pictures we do in an experiment that can prove that our experiment is do successfully. For part 1, VB is 12.09 watt, VE is 11.48 watt, VC is 24 watt. For part 2, Vout is 150 milliwatt, Vin is 185 milliwatt. For part 3, Vout is 150 milliwatt, Vout over 2 equal to 75 milliwatt. Rout equal to 14.82 ohm. For part 5, we can see the picture in the slide.
From analysis for part 1, the emitter current record 1.129 mA. The collector to emitter voltage record 1.252 voltage. For analysis part 2, for the voltage giant, we got 0.811. For the input impedance, we got 194.96 ohm. The current input record 0.949 mA and the input power record 1.76 multiplied 10 power -4 watt. This is DC load line analysis graph for common collector configuration and with the Q point of transistor operation. Analysis part 3, the output power record 1.52 mW. Next, the analysis part 4, the power giant record 8.64. Analysis for part 5, from the picture below, there is no phase difference between the input and output signal. Let's answer the quiz. Question 1. The common collector circuit is used mainly as impedance matching circuit. It is because high input impedance but low input impedance. Also, voltage giant is 1, make it unsuitable as voltage amplifier but excellent for impedance matching. For the question 2, the input AC signal is applied between the emitter and base. It's because the input signal modulates the voltage across the base emitter junction, which control the transistor operation. Question 3. The AC voltage giant is less than unity because the voltage giant is less than 1. Next, question 4. The output impedance is low. It's same explanation for question 1. It's because high input impedance but low output impedance in circuit. For the last question, why the common collector circuit also called as voltage follower? It is because the voltage signal output at the emitter is equal to the voltage signal input at the base. For discussion, the common emitter amplifier is fundamental single-stage bipolar junction transistor that function as a voltage amplifier. The input for the amplifier comes from the base terminal, the output is obtained from the collector terminal, and the emitter terminal serves as the common point for both terminals. The common emitter amplifier circuit during experiment commonly called as voltage divider bias. This bias configuration arranges two resistors as a potential divider across the power supplies with center point supplying the required base bias voltage to transistor. Voltage divider biasing is commonly for bipolar transistor amplifier circuits. Next, from experiment, we got voltage giant is 0.811 and it is less than 1. Also, there is no phase difference between the input and output signal of the common collector amplifier because both signal in the same phase. There is a few errors during experiment. The error is an incorrectly calibrated digital multimeter give incorrect readings. Next, incorrect connection of the components in the circuit resulting in no signal amplification. Last, temperature increase, the transistor base emitter voltage decrease, leading to a lower biasing point. The solution for the error is use the higher quality digital multimeter to obtain accurate readings. Next, check and ensure components like transistor are oriented correctly, collector, base and emitter in transistor. Lastly, conduct experiment in controlled temperature environment to reduce variability caused by temperature fluctuation. The conclusion, the input and output of the common collector amplifier are 14.82 ohm and 194.96 ohm. Next, the power giant of the common collector amplifier is 8.64. Last, there are no phase difference between the input and output signal of the common collector amplifier. There is our reference. That's all from us. Thank you.